Hi everyone, today we're looking at Module 6, Lessons 1 and 2, and we're focused on making linear representations of functions. So Lesson 1 says modeling linear relationships. And we have a few objectives for today. The first is that students determine a linear function given a verbal description of a linear relationship. And that's going to be between two quantities. So when we have our x and y variable, based on a description, we should be able to show the graph. Our second objective says students interpret linear functions based on the context of a problem. And the third is that students sketch the graph of a linear function by constructing a table of values, plotting points, and connecting those points with a line. So we're going to start off with a little cutout that you've gotten for your notebook with a word problem and some visual representations of that data. So this problem in particular is called Logging On. And it says, Lenore has just purchased a tablet computer and she's considering purchasing an internet access plan so that she can connect the internet wirelessly from virtually anywhere in the world. The company that she's considering going with says that there is a fixed access fee for connecting. And the website says that for 10-minute sessions, she's going to pay 40 cents, 20-minute session, she's going to pay 70 cents, and a 30-minute session, she's going to pay $1. And Lenore decides that she will use this information to determine the fixed access fee and the usage rate. So the first thing we kind of want to look at is her plan linear? And by connecting those 3 points with a straight edge, we're showing, yeah, it does look linear, but can we prove that mathematically? So what we want to do is examine the constant rate. Constant rate is the change in the y values over the change in the x values. And when we examine each set of coordinates, we see that we're increasing on our y value by 30 cents and increasing on our x value by 10 minutes. So this is consistent throughout the data. By using that pattern, we can also identify the fixed rate, which is going to be our y-intercept b, is equal to 10 cents. And we just did that by looking at our 10-minute mark and subtracting that 30 cents according to our constant rate. Module 6, Lesson 2 is interpreting the rate of change and the initial value. Students interpret the constant rate of change and initial value of a line in context. We'll also expect that students interpret slope as rate of change and the steepness of a line. So we're just looking at trends at this point and thinking about what components of our function represent which piece of information. So when I looked at that problem regarding internet access, I had a fixed cost and a cost per 10 minutes. If I have a similar scenario where I can purchase MP3s at an initial cost of $3 plus 25 cents per song, Both of those values exist in my equation.